We start with an overview of the ZTAG data exfiltration scenario architecture. We have an over-provisioned analyst who attempts to exfiltrate their data to a remote workspace. This workspace is secured by CrowdStrike Falcon for endpoint protection and detection, Zscaler private access to manage secure network access to internal applications, and Zscaler internet access to secure user access to the public internet. The data resides within an Amazon S3 bucket and is fronted by a storage gateway file gateway and accessed via XQ message vault. Additionally, the user is attempting to access files from a device that is lacking critical updates. The user's actions and logs will be flowing into Splunk Enterprise Security, which will allow a SOC analyst or incident response team to be able to view and get information on what actions the actor has conducted. Splunk SOAR is utilized to trigger runbooks based on device signals and user actions to automatically adjust permissions and revoke access as events begin to occur. Persona 1 would be the actions of a typical user. The analyst would make a call to Service B, Amazon's API gateway endpoint, in order to export sensitive data, and this data could be something that's used in their everyday role. They're going to be exporting it so they can conduct additional further analytics from their workstation. Service B produces an encrypted file and stores it within Amazon S3. The S3 bucket is mounted as an SMB share by utilizing Amazon Storage Gateway File Gateway, which is taking advantage of XQ Message Vault in order to then be able to access those files. Persona 2 would be where we have a threat actor. In this case, the analyst is now going to attempt to exfiltrate that file to their workstation in order to remove it to an external target, such as a USB drive or a cloud online storage account. Persona 3 would be a security analyst. We will be seeing the attempts and alerts as they are occurring, being sent into Splunk, and then over time, that analyst's permissions will be revoked and then completely disabled based on the runbooks that have been configured. And here is a complete overview of how the entire architecture ties together. During this demo, I will be taking on Persona 2, an analyst who is attempting to exfiltrate data from a shared drive to my workstation and then trying to upload that to a cloud storage account. On the right hand side of the screen will be my workstation, which is powered by Amazon Workspaces. And on the left, I will review the live data as we are receiving it from CrowdStrike Falcon sensors, Okta, and XQ Message as it all flows into Splunk. We start by authenticating into XQ Message Vault via Okta. We use Okta Verify on a registered device and are integrating CrowdStrike Falcon's Zero Trust assessment into our Okta authentication policy. This provides real-time security and compliance checks for endpoints to enforce conditional access based on device health. Once authenticated, we use Vault to connect to our SMB share. By separating tool access from data access, XQ secures and controls your data across all platforms, eliminating any gaps in data governance. This allows you to take control over who, when, and where your data is viewed and shared. And to back this, we're taking advantage of Amazon Storage Gateway File Gateway as our SMB share. This enables you to store file data as objects in Amazon S3 cloud storage. Now let's take a look over what you didn't see happening in the background. First, we have our CrowdStrike Zero Trust assessment. Here we can see that this device has a score of 19. We can see why our device has that score as well, based on requirements that are being met and not met within CrowdStrike's list of OS and sensor assessments. The first place we are utilizing this assessment is within Okta's authentication policy. We have a rule in place that if a user's overall ZTA score is less than 25, then they must use an additional password on top of Okta Verify. Within our logs, we have a ZTA score coming in as part of the device integrator. Again, we can see the OS score is 46 and the overall assessment score of 19. Additionally, when our user logged in, that ZTA score was used to determine whether the user had access to a specific group. Our user was originally within the US tactical group, but because of that low assessment, they were moved to the quarantine group. Now let's jump back over to our workspace and take on the persona of a malicious user attempting to exfiltrate data. The first thing they might try to do is open a file with CUI in the name. Here we are able to see that we're not able to access that. Let's take a look at the public files. Those are accessible, so let's try to exfiltrate those. The first thing a user might try to do is drag those files out of the folder. And here we can see XQ copy protection prevents the moving of secure files. What if I try and copy paste it out? Copy protection kicks in again and prevents me from doing that. XQ Vault also controls what applications can and cannot open a file type. Earlier you saw that I opened a CSV with Notepad. Now if I try and open it with Notepad++, it fails. What if I try and take the raw files out of the SMB share? When I open the folder, we can see here that the files are a XQF file type. Those are encrypted and stored by XQ. And if we try and open those, we see I fail. And even if we were able to open those, they would just be encrypted gibberish. And again, XQ copy protection kicks in here as well, so I can't even exfiltrate the raw files. Next, let's take a look how this is working within the XQ Management Console. Within the XQ Management Console, we have configured a policy that if a user falls within the quarantine group, then we deny access to any files that have the metadata labeled with CUI. We have an additional policy in place that automatically labels the metadata based on a file naming convention. Now let's take a look at our Enterprise Security Splunk Cloud instance. We can see the user risk score is beginning to increase based on those activities the user has been taking against the files. We're getting logs from XQ showing what suspicious activity the user has been taking. So we're preventing the attempt to drag a file to a different location, preventing access to a file with an unauthorized application, preventing the copy and pasting of a file out, and all of these were blocked and logged. Additionally, XQ has webhook integrations with Okta. So as a user's group memberships, permissions, and account status change, such as their account being suspended, so will their access to XQ and their Vault account, which will be disabled and they will be logged out of Vault, which you can see just happened to our user. At this point, the user might try to log in again and see that their account has been disabled, and maybe begin to panic and try and cover their tracks. They try and install some malware on the device in order to corrupt it, and additionally might try and exfiltrate what they can, in this case just a screenshot with the file names. So if I open up Snipping Tool, take a screenshot, save it, and try and upload it to an online storage account, in this case I'm logged into my personal Box account, this is where our secondary DLP protection endpoint kicks in. So Zscaler is taking advantage of OCR, optical character recognition, to scan the upload for any keywords, and if found, block them from being uploaded. And while all of this is going on, all of this data is continuing to flow into Splunk, and that malware that I tried to deploy earlier, CrowdStrike Falcon picked up on that, and a runbook is used to isolate the device and lock out access. You saw here how the AWS Zero Trust for Government partnership unites public sector security leaders to help secure your environments. This strategic alignment improves architecture, increases security while maintaining operational flexibility, and simplifies compliance. AWS and AWS partners can help you boost your security posture by providing data security, endpoint protection, identity management, security analytics, and device and network infrastructure.
Hello everyone, I'm your Security Operations Analyst, and today I'll be guiding you through an in-depth demonstration of a Department of Defense aligned Zero Trust security implementation. Our security operations leverage an integrated security stack designed to provide comprehensive visibility into our environment security posture. The Splunk platform aggregates real-time logs and security telemetry from multiple security tools, such as AWS Security Hub and Amazon Guard Duty for enhanced threat detection and security validation across our cloud infrastructure, XQ Message for data protection, CrowdStrike for advanced endpoint detection and response, Zscaler for zero trust network access, and Okta for identity and access management. This integration enables continuous monitoring and analysis across our digital infrastructure, supporting our implementation of zero trust security controls. Now, let me walk you through our Security Operations Command Center. What you see on the screen is our command center's primary interface powered by Splunk Enterprise Security. This provides centralized security monitoring, risk based analytics, and threat detection across our zero trust architecture. Let's begin by examining our executive summary dashboard. This interface, which you see here, provides real time visibility into our security posture. Notice the color coded panels representing our notable security events. These are characterized by severity and relevant security domains aligning with the DoD's risk management framework. What catches our attention today is a concerning pattern of security events. We are observing a high volume of notable events from various sources. Specifically, we have malware detections coming in from CrowdStrike. There is also a series of unauthorized access attempts to sensitive applications coming from Okta. Additionally, we are seeing potential data exfiltration signatures with suspicious file operations coming in from Zscaler and XQmessage. To understand this better, we have created an extensive dashboard that aggregates data from all our security tools. This gives us a complete picture of users' devices and their transactions within our Zero Trust framework, allowing us to focus on high risk incidents. Let's examine the case of user 51, who has triggered multiple security controls and currently shows a critical risk score displayed in red. The timeline for user 51 begins with an attempt to access sensitive applications, specifically the XQ Vault through our Okta portal. This is where our Zero Trust engine springs into action. It initiated an immediate device security assessment through CrowdStrike. The system evaluated multiple security parameters, including device posture, patch status, and security configurations, returning a zero trust assessment score of 19, well below our configured threshold of 25. Based on this failed security validation, our automated response system immediately moved user 51 to a quarantine group. And you can verify this action in the group membership logs displayed here. This demonstrates our implementation of DoD's principle of continuous verification and automated response to the security posture changes. Now, let's examine the file monitoring data from XQmessage. We can see an attempt by user 51 to access controlled unclassified information. Due to the user's quarantine status, this attempt was automatically blocked. The system logs also show denied attempts for both file viewing and copy operations for this user. This showcases our enforcement of least privilege access and data protection, key tenets of the DoD's zero trust model. Moving to our data exfiltration monitoring, we detected three specific attempts to exfiltrate sensitive files. XQmessage automatically blocked these attempts, and a file-centric view here shows exactly which files were targeted and what actions were taken to prevent unauthorized access. Concurrent with these events, our network security monitoring through Zscaler shows suspicious patterns in user 51's internet behavior. Starting from an overview of activity types to specific file share destinations over the internet, we can see the user attempting to exfiltrate data over the network. Notice these spikes in file sharing attempts to unauthorized destinations. The Zscaler optical character recognition technology detected attempt to exfiltrate screenshots of sensitive documents, resulting in 5 blocked transactions with 403 errors. This showcases our implementation of DoD's requirement for advanced network security and data loss prevention. The situation escalated when CrowdStrike detected malware on user 51 device. This detection, combined with previous suspicious activities, triggered our automated incident response playbook on our security orchestration, automation, and response platform. Now, let us look at how these findings tie together to give us a complete picture. Moving to Enterprise Security Risk Analysis panel, you can see how each security event contributed to user 51's overall risk score, classifying it as an extremely high risk user. Our security intelligence engine correlates these events with MITRE ATT&CK framework to provide context and determine appropriate response actions. This approach aligns with the DoD's requirement for continuous risk assessment and adaptive security controls. Finally, let's examine our SOAR timeline. We can see the complete sequence of automated responses from initial zero trust authentication failure and quarantine to the removal of the user from access groups to the user account suspension and finally the user's device getting quarantined. Let's open one of these artifacts to look at a playbook in action. As we can see, the conditional access system verified the device security score and based on that removed user 51 from the US tactical group and added them to the quarantine group. To wrap up, this incident perfectly illustrates five key principles of our DoD aligned Zero Trust implementation: continuous monitoring and validation, least privileged access, micro-segmentation, explicit verification, and automated response. By integrating these principles with advanced security tools and automated responses, we have created a robust security posture that can rapidly detect and contain threats while maintaining detailed audit trails for compliance and investigation purposes. And to assist government agencies in implementing zero trust architectures, AWS has launched the Zero Trust Accelerator for Government program. This initiative aims to assess agencies' current zero trust maturity levels, identify gaps in existing security frameworks, and develop customized roadmaps tailored to specific requirements and budgets. Scan the QR code on the screen to know more about this program and how to contact us.